Hello and welcome to AWCI's webinar. My name is Anne-Marie Salvatelli and today's webinar is Interior Finish Firestopping and is sponsored and presented by Specified Technologies Incorporated. Before we start, I have a few housekeeping items. Attendees should be on mute throughout the entire presentation. Should you have a question at any time during today's broadcast, please submit it by using the question box in your GoToWebinar dashboard. And then following the presentation, we'll have a short Q&A session. Handouts are available for download in your handout tab. And a recording of this presentation and all handouts will be sent to registrants within the next few days. At this time, I would like to introduce our presenter. John Zalepka is the Director of Training and Industry Engagements at Specified Technologies Incorporated and is responsible for the accreditation and maintenance of all CE training, including the widely specified Firestop instructional training and all AIA modules. Previously, as a territory manager, he worked in the trenches alongside contractors and brought this real-world experience into the classroom. Welcome, John.
All right, thank you so much, Anne-Marie, and welcome everyone to Interior Finish Firestopping. So this is a cornerstone of fire safety in modern buildings, and it plays a vital role in containing fires and the other products of combustion to the point of origin. And this helps to preserve escape routes and save lives at the end of the day. And in today's session, what we're going to do is we're going to dive into the essentials of interior finish fire stopping and what construction joint system design is all about. And you're going to learn about the different joint types, the rigorous testing methods that we use as manufacturers, and how to confidently choose the right system for your next project. So we did make all of the slides available. It is copyrighted material, so please do not reproduce or redistribute any of that without contacting us first. We do like to educate the industry, but here's the learning objectives for today. By the end of the program, you're going to be able to identify the different joint types, recognize the differences between what a static and a dynamic joint is, describe the different ratings of floors and walls, what they're all about, and understand the difference between a rated and a non-rated partition. And we're going to break it down like this. Here's the agenda. We're going to start by exploring the fundamentals of fire stopping and the keys to code compliance. Then we're going to dive into how us as manufacturers test these products and these joint systems and walls and floors, and then just to make sure that they're meeting the required safety standards that have been set forth by the industry. Then we're going to discuss joint movement, proper product installation, and some of the necessary steps to making sure that you get it right so that you don't wind up on the redo list. So we always start with this. It's kind of crazy to think that life safety systems that are required by code are not necessarily tied to a certain trade. The ones that you see on the screen are those. So, I mean, these people live and breathe life safety systems when it comes to spray applied fireproofing, sprinkler systems, alarms, damper ducts. And the common theme is that these people live and breathe these life safety systems, and it's very much contingent upon the installer to get it right. But fire stopping is a little bit different. It's kind of unlike these in that there doesn't neatly fall into the scope of work for any one contractor. Sure, when we're talking about interior finish, a lot of times it falls to the drywall contractor, but is it the insulator? Is it the person that's sticking that conduit right there through the wall? There's a lot of different types of fire stopping, and that's why, you know, a lot of times you get a lot of finger pointing. Low man on the totem pole gets handed that caulk gun there, and they say, go, you know, install some fire stopping system. So a lot of times it's really vague instructions, and it's just, you know, go fill these holes over there. So typically, we see a lot of times wrong products are being used or specified. Just because it's red and just because it says fire stop on there doesn't mean that the drywall contractor can use the same product as that electrical contractor there. So there's no universally recognized licensed trade at this point in time. So we rely heavily on things like education, like we're doing here today, so that you understand that fire stopping is really all about sealing all of those openings for penetrating items, or in the case of our construction joints, those linear gaps that are left open, typically because of building movement. You know, we want to make sure that the wall and the floor is going to move together. So there's different types of systems and different testing when it comes to, you know, your penetrations for your typical mechanical, electrical, plumbing type contractors. We'll throw those sprinkler folks in there as well. They're knocking holes in walls. Your data communications, these are the folks that are wiring up the building for your Wi-Fi, your different, you know, service lines and things like that. So there's a lot of low voltage lines that will penetrate walls. But what we're talking about when we talk about interior finish is typically those construction joints that you see there on the right-hand side of the screen, where your drywall is coming up to the underside of a concrete deck, or maybe you have two walls coming together or two floors coming together. So that's what we're talking about with those joints there. So that's how we kind of break down the different fire stopping examples there. And the products, you'll see here a couple typical products. These are products that are tested to third-party standards at third-party labs. And, you know, a few of them that you'll see there. On the left, we could see a typical head of wall joint where the top side of the gypsum wall is going to meet the underside of concrete over some type of steel fluted decking there. Next, you see those data communications cables going through a fire stopping device. Then we could see a cable ladder with pillows. These are reentrable. You can actually take those out and put them back in. And then we could see a typical plumbing pipe going through a gypsum wall there using some type of an intumescent sealant to seal that up. But again, these products are part of systems, so the products themselves don't have ratings. So be careful if somebody says, go grab the 2-hour caulk. It's just not a thing. It's all part of a tested system. And we'll show you where you can find those systems and why they're required, because nobody fire stops for the fun of it. I promise you they don't. It's required by code. It's been in the codes for north of 30 years at this point in time. Every 3 years, there's code updates. So if you're talking about a building code, typically you're familiar with the IBC, the International Building Code. This is your model building code. So even regions in California or Las Vegas or different local codes like New York City are typically built off of this model code. But again, you'll see different standards called out in this code, and they've been updated and refined and clarified over the last 30 years, like I said. And every 3 years, you'll see this. So we see right now on the screen your 2021 code in a lot of jurisdictions now at this point in the States. You'll see that that's being adopted. And if you did look at that, this is where you would find the requirements for your fire stopping. So on the screen, you can see the IBC will point out where you're going to find your through penetrations for your walls and your floors, your joint systems. Again, those are your construction joints. And then there's also a section for your exterior curtain wall systems there, that perimeter fire containment. So what you're seeing is the 2021 edition on the screen here. And what you need to know is, even if you're on a job where the 2018 code is in effect, or maybe even 2015, depending on when the plans were filed, or perhaps you're in a really forward-thinking jurisdiction and they've already adopted the 2024, which is out there, you're going to find yourself within 1 or 2 decimal places of these code requirements. So you just need to know that they're required by code, and if you didn't believe me, there's where you can go and find that. So when you're on the job site, where do you fire stop? I mean, that's a great question. If you see a hole, you should seal it. No harm is going to be done, especially if you put fire stopping in there. What you're going to want to do, though, best practice is get your hands on the life safety drawings, your building plans. This is going to tell you, it's going to be your most reliable source for what the rating is. Is it 1 hour, 2 hour, 3 hours, things like this. So depending, though, you might be in an older building and you're on a renovation project, and they might be misplaced or outdated or just missing entirely. So you're going to need to look for things that are typically in fire rated construction, like you see fire rated doors. You could see stenciling, which is typically required by your code there to tell you that that's a 2-hour fire barrier. You're going to protect all your openings. You see things like windows and damper ducts. So this is a dead giveaway that that was a fire rated assembly at some point in time. But hopefully you're on a project where the architect is clear, the drawings are clear, you have these life safety plans, and this is where you can find out what is a fire rated wall and what is not. So let's talk about the types of fire stopping that you most likely will come in contact with, and this is going to be those construction joints. So your International Building Code will define your joint as essentially the opening in between 2 adjacent assemblies created to allow for movement. And you need to make sure that your 2 adjacent assemblies are rated, right? So we can't have a non-rated wall meeting a rated wall and expect to have a fire stopping system. Now, again, these control joints a lot of times are built into your non-rated walls as well. So you want to make sure that in those non-rated walls, you can get away with using a smoke and an acoustical sealant. But if you do that in your rated walls, you're probably going to have to go back once they realize you used a non-rated product there. So just to make sure that, if you do have that work, that you know which product you are going to use. UL will define your joint system as follows. Again, you have those two adjacent assemblies and that linear gap that you need to protect to stop the passage of fire and smoke from going through there. So pretty much drywall is considered flexible, and because of control joints, it allows them to be flexible. So we need to make sure that the products that we're using in those joints are also flexible. Another code section that you want to make yourself aware of is this is where you can see that the fire stopping for these control joints, and you'll notice at the bottom there is at 715.1, the fire rated joint shall be tested in accordance with 715.3. So what is 715.3? So if you look closely there at the bottom, it says that it needs to be tested in accordance to ASTM E1966 and UL 2079. And these are going to be the test standards that we use as fire stop manufacturers to test the different assemblies to get those 1, 2, 3, or even up to 4 hours. The test standards are a little bit different. You can see for your through penetrations, and the reason that I'm pointing these out to you, you don't have to memorize these numbers, but you do need to know that they exist because they're going to show up on the products themselves, on the UL systems, on the product data sheets. And you need to make sure that if you are dealing with a joint application, that you're using a product that's been tested to ASTM E1966 and UL 2079. So you can see the different test standards for your through pens, your joints, and your curtain walls there on the screen. ASTM will typically give you an F and a T rating, so your fire and your temperature rating. In joint systems, we call this an assembly rating. And then UL, typically they'll build on those F and T's and give us things like smoke leakage, which is important on the next one, and also water resistance, so washout W ratings as well. The reason I bring up the L ratings is because this is something that a lot of times contractors do not consider when they're faced with a smoke barrier. So smoke barrier, as you see here, is really a fire barrier. A lot of times people call them smoke walls, but they're not smoke walls. So you're going to have smoke barriers and you're going to have smoke partitions. And as manufacturers, we get this question all the time. Well, what's the difference? Well, you can see here on the difference is the code outlines your barriers as needing a 1 hour fire rating as well as stop the passage of smoke, which means you also need to have an L rating for smoke leakage. Whereas your smoke partitions, you just need to have a material that's been approved by your local authority having jurisdiction that's going to stop the passage of smoke. So if you're familiar with smoke and acoustical type of sealants, that's what you would use on your smoke partitions. But your smoke barriers, you actually need a fire stop product that is going to stop the smoke as well. So just showing you that last section there where you need to make sure that your smoke barriers are stopping the fire and the smoke. There is where you would see an L rating on a UL system there. So you need to make sure that you have an L rating that's less than 5 CFMs, that what is allowed by the code. So if you are working in smoke barriers, just be cognizant of the fact that it's not just a smoke wall, it's a smoke barrier, and it's definitely different than a smoke partition. All right, so now we're going to cover how we test these things at the third-party testing agencies. Now that we know the standards that we use to test them, and here are a few different labs on the screen now. Many people, when it comes to fire stopping, are familiar with UL because, let's face it, 95% of the through penetrations anyway are probably listed at UL. But Intertech, FM Global puts out FM approvals. So there are testing agencies that aren't just UL. So it's not always a UL system, even though probably 9 times out of 10 it is. But these are the third-party labs that are capable of running the tested and listed standards that we just showed you on the last screen there. The code doesn't say where the test has to happen, just that you need to conduct it to those ASTM and UL standards that we just took a look at. So there are testing at all of these, but if you're, like I said, 9 times out of 10, you're going to have yourself a UL system. So understanding the nomenclature on there will help you get into the ballpark to make sure that you have the right system, even if you've never fire stopped before. So taking a look at the UL system, following this approach here, we always start with a system. Again, you may have a product on hand, could be the perfect product, but if you don't have a system, you're never going to know how to install it properly. So making sure that we have the right system starts with understanding and identifying the proper joint there. So if we're looking at HWD 0043, that's our example there on the screen. We could see that the HW would stand for head of wall. Floor to floor, wall to wall, floor to wall. The nomenclature is very easy. They're not trying to trip anybody up there. So your HW will stand for head of wall, and then the next letter that you come to in the system will tell you if that joint moves there. So if you come across the D, that means that it's dynamic. That means the joint has been tested, it's been cycled for movement. There's different types of cycling and different movement classifications that we'll talk about, but knowing that the D is there knows that that joint can move. There are some static systems, and we test static systems for a number of reasons. There may be a product that cures hard. We might have an intumescent sealant, which is typically used around the pipe, but a drywall contractor may have used it at one point in time at the head of wall, and probably more than once, which is why we tested it. So we could have a product that is capable of stopping the fire but doesn't allow movement, in which case you may see an S in a system there. Could also be the construction of the wall. If it's two planes of a wall moving together, you're not going to get compression and extension, so they're going to kind of move together. So that could be a static system as well. But that's what it'll tell you if it moves. And then the first number that you come to in UL systems will tell you the range possibility of that joint system there. So in this example, 0043, this system can have a joint size up to 2 inches, but always be aware you have to check the system card. The manufacturer may not have tested all the way up to 2 inches in a certain joint configuration. I can tell you in this example here, the maximum joint size is actually 1 inch, where the drywall meets the underside of the fluted deck there. So you have to make sure to check the system cards. Just because you see a 0 doesn't mean that your joint can be 2 inches. It just means that that's the range of this system numbers. And then finally, the last 3 or 4 numbers, you'll see that little underscore there. UL is actually run out of certain classifications of numbers. So HWD 0999 will be the 999th system, and then they're just going to add a digit after that. This way they don't have to change the nomenclature and the leading number there. So that'll tell you who that system belongs to. So 0043 is an STI system. There will not be another manufacturer with that number. They may have a very simple or a similar tested system. They're just going to have a different number. All right, so a few things to consider when you are selecting the correct system is what is your joint size? This is always going to be a big consideration with different types of products that you can use. You may need to have backing material that's required depending on the joint size there. Your assembly ratings, I should put ratings on there. It says assembly rating. We need to make sure that both assemblies have a rating. Again, you could have a situation where you have a 1-hour wall meeting a 2-hour wall. The best that you could hope for at that point is a 1-hour fire stopping system, because one of the assemblies is not rated for 2 hours. So it may not last for 2 hours. So the system will go when the wall goes. Movement, compression, and extension, again, depending on where you are. If you're in California, there may be seismic requirements that allow for 100% compression and extension. So you may need to use sprays and different types of flexible materials. And then mineral wool, a lot of times this is absolutely required. Orientation of mineral wool fibers and compression could be a factor in there as well. And then sealant depth or spray depth is always going to be something that you need to consider when you are looking at the system and going to install it. So taking a look at that example that we were showing you earlier, HWD 0043, the parameters will all show up on that system card there. Again, you need to make sure to verify what the building assemblies are made out of, concrete, gypsum, whatever it is. Again, concrete over fluted deck is a different type of an install than a flat slab condition there. You may be able to use some type of a gasketing material like track top gasket if you had a flat slab, and you don't necessarily have to bring mineral wool and a spray rig on site there. So again, all of the questions that you see there on the screen will factor into what system number or what system you're going to choose, including special requirements or special considerations. So we always point this one out because we want to make you aware of it, especially if you're the installing contractor. You see that little number 2 there on the right hand side there in the little diagram? That's the sprinkler pipe. And we test for it with the sprinkler pipe through there because we know it happens. But if you know the sprinkler contractor and you're on the job site, tell them stay away from my joint. We always recommend at least a 6-inch no-fly zone, because when you put that in there, you're actually going to compromise the temperature rating, which is going to hurt your assembly rating, which could hurt your code compliance for a perfect install. You're going to have that pipe through there, and it's also going to compromise the amount of movement, because if that sprinkler pipe moves, it's going to tear your seal with it. So tell those sprinkler guys, stay out of my joint. That's just my recommendation for you. So now we're through the testing section. Let's jump into the different types of joints that you might find at different fire rated construction, your walls and floors. You're familiar with a lot of these if you're building the walls. UL is always going to have a classification as you build the wall, as the gypsum manufacturers test their walls on the steel studs, on the wood studs. We all go to these third-party labs and we test the certain time temperature curves to make sure that the assemblies themselves will stay there for the 1, 2, 3 hours, 4 hours, whatever it is. So there's wood studded walls, you have steel studded walls, you have your shaft walls, and all of these different assemblies are going to have their own Firestop testing. So just make sure that depending on your wall type, the U, V, W, 300, 400, whatever it is, that is specifically listed on the fire stopping system that you're choosing. Some of your floors that you may come across out there, of course, we've talked about the concrete over fluted decking, but you could have that flat slab poured in place concrete there. In the center, that's that one that we've been talking about. On the right hand side, you may come across some precast hollow core floor assemblies. These make for some very interesting, especially through penetrations through there. You have a lot of extra opening to account for, and again, depending on where that open core might be, in line with the joint that you're trying to protect, you may have to deal with that at some point in time as well. So just make sure you know what the slab is that you're dealing with, your floor assemblies, and then again, you're going to want to grab your life safety drawings, your architecturals. They're going to show you how all of this comes together. Again, it's crucial that you familiarize yourself with these life safety drawings, because they're going to provide, when you have a 1 hour or 2 hour wall, whether it's a shaft wall, your smoke barrier. Again, don't forget, you need to make sure that you have a fire stopping system on those smoke barriers. But again, you need to understand that there's some distinctions in the wall types there, and you just want to make sure that you have the code compliant, because at the end of the day, you want to get it right so you get paid, but you also want to have a building that you leave behind, because God forbid there is a fire at some point in time. You want to make sure that you're not the reason that people die. All right, so now that we're through the wall and floor construction, let's talk about the different joint types that are out there. Again, the joints are those gaps that are intentionally left there for the structural members of a building to move, again, without causing damage. A lot of times, if you have the drywall that's right up against the concrete floor, there's going to be load movement, so there's going to be some cracking, and you just want to make sure that you're building it to the architecturals, the engineers. They kind of figured this out, how much movement you need, how big your joint should be. So here are the 5 types of interior finish joints that you'll typically see there. Again, your wall to wall, where the 2 walls will intersect. 2 floors may come together. Your floor to wall, this is a little bit different than you would see around the edge of the slab. Your curtain wall, this is going to be a rated floor to a rated wall. Your curtain wall is going to not be rated, so that's why that's a different test standard. And then your head of wall there, that's what people are most familiar with, those partition heads. And bottom of wall, a lot of times it's not necessarily required by code, but it is a best practice, and it does stop the smoke and other cool air from coming in and making that fire burn even hotter. So I want to make sure that you're doing whatever it is, not only required by code, but it also may be a specification that the architect put in there for bottom of wall fire stopping. So always make sure that you have that. It's easier to leave yourself a gap before you put the drywall up than having to come back and cut that out afterwards there. So let's talk about the head of wall joints. Again, these are probably your most common ones that you're used to dealing with. And again, this is going to be the top of a gypsum wall, meaning the underside of any type of a decking, your concrete over fluted deck, flat slab, you name it. Again, most of these systems are going to be dynamic, and they're going to be indicated by that HWD prefix that we see there, meaning that they're going to allow for movement. And taking a look at the top of this system card here, we can see that it has an assembly rating of 1, 2, 3, and up to 4 hours. And this is really going to be contingent upon how the wall is built. So usually it's 1 layer on each side, 2, 3, and 4. We'll give you those 4-hour ratings. And then underneath that, you can see where it says Class 2 movement capabilities. This is where that joint needs to move 40% or 50% compression and extension. So we need to make sure that that joint is going to stay in place and that seal does not rip. This is why having an elastomeric type of a spray that you see the gentleman putting on there, you need to make sure that that is going to be the preferred solution. It's fast to apply, and it's going to give you a lot of that flexibility that you need, especially if you have something where you need 40 or 50% movement. All right, and then bottom of wall systems here, again, as I mentioned, most of the time, not necessarily a code requirement, but if it is a specification requirement, it is a best practice. You'll see that a lot of the times those bottom of wall systems are static, meaning they're not going to move. There's not going to be compression and extension. But again, sealing those will stop that cool air that kind of works like a convection oven in an actual fire event there. So if it is part of the specification, leave yourself that little control joint down at the bottom there. So there are some tested systems that will get you that hourly rating back. So your wall-to-wall joints here, again, these can either be dynamic or static. Again, you'll see WWD if they're dynamic, WWS if it's static. This particular joint is designed to move in between 2 concrete or CMU walls there up to 3 hours. So it actually can accommodate a maximum joint width of 1 inch and offers 2 inches of Class 2 movement capability. So again, using some of that backer rod there, it may be required per the system. It may be optional. You're always going to want to check the system card to know whether or not you can use a certain material. So here's a floor-to-floor example there. So we'll see this a lot of times, expansion joints or different control joints, again, and your floors coming together there. So this example is going to highlight FFD 1010. This is going to provide up 1 or 2 hour system. You'll see there with a maximum joint of 4 inches. And the system is going to allow varying levels of movement depending on the joint width and the hourly rating, with options for 15, 25, 35% you could see there. So again, depending on how big the joint is will vary how much flexibility there is. So to ensure that you're compliant there, you always want to make sure that you read the system before you cut the joint, because it's always easier to do it that way than have to come back later. And then finally, floor-to-wall systems here. Again, this is different than those perimeter fire containment systems where that curtain wall is not going to be rated. This is some type of a rated wall. So you're going to have a dynamic or static a lot of times there. This is going to show you a dynamic system that we have. FWD 1006 provides a 2-hour rating and can accommodate a maximum joint width of 6 inches, offering a Class 2 movement capability with 15% compression and extension. Again, if you're dealing with interior finish, you are dealing with movement most of the time. So check those architecturals, make sure that the systems that you're choosing are going to allow for the movement that is set forth for what your plans are saying. So let's talk a little bit more about that movement and how that we can ensure that the products that we are offering and the systems that we're offering there actually work. Excuse me. So we've kind of discussed at length why joints are designed to allow for that movement, but this is how kind of the rubber meets the road and how we know that certain products and certain systems will be able to stand that test. So the movement testing is conducted before we burn the joints, obviously. This is going to stress or essentially weaken them, the materials, making them burn making the burn portion of the test even more critical, right? So what we're going to do is we're going to stress it depending on what the class movement is. So you can see on screen here, there's 4 different classifications of movement there. So if we're just going for thermal, we're doing 1 cycle. So what we do is we start here, we go up, we come down, and we push it, and then we come back, and that's 1 cycle. So we'll do that once every minute, 500 times. If we're doing wind sway, so in places like Florida, there might be hurricane requirements, so they might ask for class 2 movement. Again, seismic in California, you have earthquakes, things like that, so they may have class 3 requirements. And then class 4, there could be sometimes where there's a lot of different movement that's going on in a building for whatever reason, where they might want all 3 of those. So you'll see the cycling rate increases, the number of cycles will increase to stress that movement there. And again, this is what we do before we put it then into the furnace there. So in a typical installation, you'll see the top track is mechanically attached to the underside of the deck, and the studs are then cut 1/2 inch to 3/4 of an inch short, nested within the slotted track, and then the gypsum is typically held down from the bottom of the deck there. So this configuration, you can see, provides the necessary clearance, allowing that top track and the gypsum to compress and extend as the floor moves, to make sure that that joint system will move with it without compromising the fire stopping integrity. So when we have spray applied coatings for especially those gypsum walls there, it's probably one of the most common methods for treating the head of wall fire rated construction joints. And that's again where your gypsum wall is going to interface at the top there, the underside of the concrete floor or concrete over fluted decking. And a lot of times, if it is a flat slab, you could just get away with a small joint and you're going to caulk it. But again, if you are talking about needing a lot of movement, you may even need something like a speed flex joint profile, which will allow up to 100% compression and extension. So this is a product that we have that you can use in conjunction with the spray. All right, and this is going to kind of give you a little illustration of what it looks like. Right, so I thought this was the coolest thing in the world to kind of illustrate compression and extension, right? And it does give you a pretty good visual of, you know, we start at the nominal width, whatever it is, we compress it, and then we extend it until someone pointed out to me that it's not the wall that moves, John, it's the floor. So I'm going to go back to marketing and tell them to have that floor move, but you get it. The floor will move and compress and extend, and it will kind of look like that, but in this case, the wall is moving there. But this kind of gives you the idea of what we're talking about when that's a full cycle there, starting from that nominal joint width. We compress it or we extend it, we compress it, and then we get those class 2 movement classifications depending on, again, how many times we stress that joint there. So, you know, going back to section 715 of the IBC there, you can see that the deflection must be accounted for with an approved joint system. So again, an approved joint system means that a manufacturer has tested it for the different movement, the different deflection there. There was a job I was on not too long ago with a contractor assumed that a noted 1-inch deflection meant that a 1/2 inch compression and a 1/2 inch extension, but the architect clarified that the 1 inch was for compression only, so it was for the basement floor. And then the joint had to be cut larger. And again, there was some rework that needed to be done. There was a little bit of confusion. They had to go back, but that's why you always want to clarify at those pre-construction meetings with your architect, your engineers, if there's ever any uncertainty, because you definitely don't want to have to go back. And I know I mentioned this a little bit earlier. It's about that no-fly zone, but this is a great little illustration of that sprinkler pipe. Again, tell that sprinkler contractor, stay out of my fluted joint deck there. Call it a no-fly zone, call it whatever it is, recommend it to the architect. This is usually what we tell architects, but if you happen to be on the job site there and you see the sprinkler contractor getting ready to run, tell them, you know, make your own hole. So again, just want to avoid any issues. It's just best to keep any penetrating items out of the joints. Again, that pipe is going to get hot in a fire and it's going to compromise the other side. So it's going to compromise your assembly rating, which means it's going to come down on you if you let that happen. So just want to point that out and make sure it doesn't happen. All right. So now let's talk a little bit about installation of these products and these systems into your fire rated joint systems. Another great section of code. I know you all love code at this point, but you can see here, according to section 715.2, the IBC is going to address the installation of your fire rated joint systems. And it says that they must be securely installed according to the listing criteria for the entire length to make sure that it remains intact. So again, if you have a gap in there, that's where the fire and the smoke are going to go there. So you want to make sure that you're stopping the passage of fire and those other products of combustion, because the smoke is what kills people in the fire. So just leave it a little bit because you couldn't get into the corner. Don't do it. Get that mineral wool in there. Get the person with the smallest hand. Get them in there and make sure that you're sealing those openings. When you're doing it, it looks a little bit like this in those fluted deck situations. Again, if you're talking about flat slab, you're putting a depth of sealant in there, usually without some type of a backer. But when you're using spray, you always need to use a backer. So again, always check your system cards. They're going to tell you those flute plugs there. Not only do they need to be friction fit in there, but a lot of times they'll call out how much compression they need in there. So there are certain systems I know where you have to compress it 14% to make sure that they're in there. You can't just willy-nilly, take a little bit of mineral oil and kind of put it in there and spray over it. You're going to use a lot more spray than you need to. We appreciate you for doing that. But no, seriously, you're not going to have a code compliant system because you're not going to have the proper backing material. When you are using spray, you always have to spray over backing material. Doesn't matter who the manufacturer is. I don't care what you've been told. You see that little control joint there on the bottom left-hand picture there, that little piece that people love to forget about. You love to cut your gypsum real tight and just run it right up to the bottom of that flute. You can't do that. You have to get that little piece of mineral wool in there, and it usually has to be about 50% compressed. So leave yourself an inch, put 2 inches of mineral wool in there, give yourself some room to work with, because again, you need to spray over top of that backing material. You can't just spray over the track or over something that's not there. So again, if you have an inspector, especially a third-party inspector that knows what they're looking at, you might have to come back. You're going to have to cut that little joint out. Then you're going to have to put the mineral wool in there. Then you're going to have to spray over everything again. So just follow the system card and you'll be good. So if you're doing interior finish, you may come across this type of work as well. I'm not sure how many people on the call are going to be doing perimeter fire containment systems, but if you're in this world and you're in the insulation world, you may. So this is a big one when it comes to mineral wool. Again, your proper compression and your orientation of your fibers is critical here. Want to make sure, I mean, the mineral wool, it will rebound as long as you have your fibers going the right way. When you put them the wrong way, they are going to get crushed, and it kind of looks a little bit like this picture, right? So on the left-hand side there, that's how we want it. So the mineral wool will often be called out, needs to be compressed 33% or 50%, and that's how we are going to compress it. That's the way we're going to be able to get 6 inches of mineral wool into a 4-inch gap by compressing it and then friction fitting it in there. On the right-hand side, you can see that's the improper way for your orientation of your fibers. So when you press that, or when it's pressed from the floor against the curtain wall, you're going to get those fibers are going to get crushed, and potentially that joint could fall out without a fire even happening. So by movement, that seal eventually is going to tear. The mineral wool fibers are not going to be able to rebound anymore, and it's just going to fall out. Plus, that's not how we test it. So it's not safe, it's not compliant. And again, if you have an inspector that knows what they're looking at, it doesn't matter that you sealed over it. They can cut it out and they can pull out post-installation destructive sampling on certain jobs. This is allowed, and there are standards for it, and they could see if your mineral wool was run the wrong way. Not to mention they can look up from underneath and see if you have the fibers running the right way. So here's a quick way to make sure that you're using the correct amount of mineral wool. For example, if you have a 10-inch joint that requires 30% compression, you don't just install 10 inches of mineral wool. You actually are going to need more when it's compressed so that it fills that joint properly. So you can see the math there. You're going to start by dividing your joint width. divide the remaining percentage after the compression, and in this case, 10 divided by 0.7 equals 14.29 inches. So that means that you're going to need 14.29 inches of mineral wool when it's compressed 30% to fit inside of a 10-inch joint. This chart is pretty cool. So again, you have the PDF of this, blow that up, keep that. It makes, you don't have to do math, right? We've done a lot of that for you there, so there's no guesswork. This will tell you how much mineral wool you need per your compression percentage. So this is what I was talking about a little bit earlier, your gun grade sealants. These are great for your smaller or your more narrow joints. Like we can see here, when you have two concrete walls that are close together, you may have some systems that will allow you to have an optional mineral wool backer. Sometimes they are required, again, depending on the size of the joint there. But a lot of times contractors like to turn to products like these because they don't require a backer there. So you can see even in the concrete over the steel fluted decking in the example on the right-hand side there, if you have that wall that's running parallel to the flutes there, that's just going to leave you a little joint there, so you can use a sealant system. And again, the benefit of using a sealant is you don't need a backer, and you don't need to bring a spray rig on site for a couple small little areas or smaller joints there. So again, the sprays might be the the preferred method when you have those larger gaps, those longer linear runs. But if you just need a quick fix or you have those smaller joints there, a sealant will do very well for you. Again, elastomeric sealant, this is going to be something that's going to dry like a rubber band. That'll be flexible with that joint, so it'll allow for the movement in a lot of those systems that we talked about. All right, so let's talk about a little quality assurance, some of the things that you may encounter out there. When you fail for a couple different reasons there. Maybe you didn't use enough product, you didn't follow the system properly, but there could be some other issues out there on the job sites that could affect a proper seal. So it usually comes down to adhesion, cohesion, or some type of substrate failure, or maybe even a three-sided adhesion issue. So we're going to go through a couple of these examples, but the first thing you want to make sure is clean the surface. You don't have to eat off of it, right? But you definitely want to clean it. You're going to have drywall dust, you're going to have mortar, you're going to have just all types of different things that are on job sites. So grease on pipes, and if you're doing things like that, but you definitely just want to kind of dust off everything to make sure that you get that good adhesion. Because if you don't, you might have adhesive failure. This could happen if the side of the joints are contaminated with oil, dust, dirt, other types of materials. The bond is between the substrates, the sealant, it might just give up, right? So to prevent this, again, make sure that you just kind of clean everything off, little dusting just before you apply the sealant. You might see things like cohesive failure. So this is going to be after your sealant or your spray has been applied and dried. It might tear apart from either movement on the joint, or it could be from either excessive movement on the joint or simply choosing the wrong sealant, or it could even be from not installing the mineral wool properly. If you have little peaks and valleys, we always tell people try to install it with flat hands. Try to get it as flat as possible. You're going to use as little of spray as possible, which is good because Firestop's not the cheapest thing in the world. But if you have those peaks and valleys, and you're going to have your sealant or your spray that's drying in those peaks and valleys, you could get that cohesive failure. And then the substrate itself, you could be working with a substrate that's weak concrete, an old type of construction, something like that. So this isn't going to be your fault. I mean, obviously if you build a bad wall, it's your fault, but you want to make sure if you're spraying on things like spray applied fireproofing, for instance, so your SFRM, sometimes you have to overspray on an I-beam that's coming through your wall there. So these systems a lot of times will tell you that you need to have 2 to 3 inches of overspray on those substrates, and that's because let's call that the substrate failure. Sometimes the substrate itself could have something on it, and that could be failing, that spray applied fireproofing. So make sure you're following the listings. Again, when you have things like that, typically you're going to have more than a ½ inch of an overspray, which is what the typical overspray is. So if the sealant is bonded to both sides of the joint, it's going to expand and contract again like a rubber band. But if it's bonded to a third point, like the back of the joint, it can no longer stretch. It's going to be torn apart because it's not going to have a bond breaker. So when you get that three-sided adhesion, you can avoid that by using some type of a bond breaker tape. Again, for any unwanted adhesion to certain surfaces. You'll see this typically in your 1-hour walls. If you have a 2-hour wall, you're probably not going to need a bond breaker tape because you're going to have plenty of room before you get back to the surface. So you're not going to want to use 1.5 inches worth of sealant in there when the system calls for 1/2 inch. Again, but if you have those 1-hour walls, you might need to get yourself a bond breaker tape. All right, so these are some questions. I don't know, do we have a chat thing? Can we put true or false in the chat, Anne-Marie? What do you think? Let's get this let's wake people up a little bit.
Yes, we certainly can. So if we want, we can do that. And folks, you can all respond by just placing a response in your chat question dashboard. And as they're coming in, some of the answers here are no.
Some
or
of the answers
false.
are all the answers are no.
Most of them so far, no.
It's not a trick question. Yeah. Make sure everybody's still awake. Yeah. So the answer is false. It means no. It is false. No color is mandated by the code. Fire stopping is all different types of color. We will see red. We've heard red is right for many, many years. But you can see silicones are like a limestone color. We have an elastomeric that we make in blue. We actually, believe it or not, we custom color different sealants and sprays for contractors sometimes. So there's nothing in the code that says that it has to be red. It's just, you know, we always get asked this follow-up question, well, where did the whole red thing come from? Back in the day, all the manufacturers said, you know what, we want it to be easy to inspect it, so let's make it red. But it doesn't have to be red. All right, here's another one. And polyurethane foam is a fire stop. Is that true or false? Or yes or no? Anne-Marie.
So far, the responses coming in are telling us false.
False. I like it. False, yeah. It is false. It is false. Again, we're not trying to trip you up here, but don't just grab anything that's laying around on the job site like this guy did there and just shoot it in there. He's like, oh, it expands. It'll make my job a lot easier. Well, it's not a fire stop. These things, in fact, a lot of times are flammable. So your inspector is going to make you cut that out if you're doing some type of that work. So polyurethane foam is not a fire stop. And I'm not going to make everybody put it in the chat. Since you're all paying attention, you know this one's false too. I wouldn't ask you 2 false questions and then make a true on you there. Joint compound is not a fire stopping material, folks. This is also a false statement. It doesn't matter how much red food dye that you mix with your joint compound. I'm not telling you to do that. I'm telling you that I've seen people do that. It doesn't make it fire stop just because you make your joint compound red. This is, you know, if it worked as a fire stop, it would be tested as a fire stop. And the people that make these types of products would have listed systems. But as such, this is a very, you know, it's water-based. It's going to crack. It's not going to move. It's not flexible. It hasn't been tested as part of the assembly. And they're going to make you cut a bigger opening out or a larger joint. So don't just fill it with joint compound. It is not a fire stop material. And yeah, so let's talk about some of the joint products. We're going to show you our products. I asked our competitors for pictures of their products, but they didn't send them to me. So we're going to show you our products, but this is in no means telling you to go and buy our products, but feel free to. So we're going to show you a couple of different joint products that are manufactured out there. And again, your manufacturer of choice probably makes something similar. But if you want STI, these are the products that you would ask for at your local distributors there. So we have sprays, we have sealants, we have gaskets that can help you out. We showed you that's, you know, fluted decking. You need an elastomeric spray. Ours is called AS. Again, this is something that is good. It can move up to 100%. So some of that movement that we talked about there, check those system cards. You can use it with just standard mineral wool. You can get up to 50% compression and extension. I mentioned earlier about a joint flex profile. This is a product that we have that will actually allow up to 100% movement with this elastomeric spray. Going right along with that, you're going to have elastomeric sealants. Again, this is going to be your gun grade for smaller joint sizes. You're going to get testing up to 4 hours with this, but you'll see you don't get quite as much movement there. So you have 25% compression and extension. And both of these products are 100% paintable once they're dry. So that's pretty cool that we manufacture it in not only brick red. So if you do like red, we have you covered, but we also do a pale blue, and we can manufacture it in white as well. So for aesthetics, if it is going to be exposed or you do need to paint over it without a primer, this is going to be a good product for you. We do have another joint sealant, which can also be used around some type of non-combustible penetrant, so metallic penetrating items. So if you don't need quite as much movement, we have a product called endothermic. This is LC, it's called, and it's going to absorb heat. It's going to release moisture that's bound within it. It's paintable again, and it's going to support movement up to 12.5%. So if you don't need quite as much movement, this is going to be a perfectly acceptable product for you. And then, as I mentioned, you're going to have smoke partitions where you're not going to need to have an hourly rating there. This is where you're going to use products like smoke and sound, your smoke and acoustical sealants or sprays. This is what ours looks like. We manufacture it, as I said, both in a gun grade sealant and also spray for your larger joints there. And this is going to help to reduce the sound transmission and other dust and airborne particulates. Again, it comes in white and it's paintable when it's dry. So a nice product for your smoke partitions. Again, we showed that little picture there, smoke partitions. Don't use this one on your smoke barriers. It's non-rated. I mentioned the SpeedFlex joint profile again. So if you do need compression and extension up to 100%, this is the product that you use in conjunction with the flute, the mineral wools in the flutes, and this will allow you to kind of get that compression there. It also is a get out of jail free card kind of. If you did run your gypsum board to the underside there and you don't want to come back and cut a joint out, this would actually allow you to just staple it to the wall and you could spray over it and kind of save the day a little bit for you. If you want to fire stop as you're building the wall, there are now gasket materials out there. This is ours. It's called TTG. This is the track top gasket. It's going to make short work of any type of construction joints where you have that flat slab condition. We actually are now making it with a little foam on there. So this way, if you get a little wavy on the underside of your deck, it'll actually seal that very nicely there. What's cool about it is it's got a lot of different applications, and you have to get up on a ladder to shoot that track anyway. You might as well just roll it out. So you can see it comes in rolls. So you see the gentleman there, just 10-foot length or whatever the length of your run is. You could tape it on. There's some PSA tape on there as well. You could stick it on there. But honestly, once you shoot it to the deck, that's all you have to do. It's in place, and then you can put your drywall up afterwards. So that's kind of what it looks like. Again, you're fire stopping as you're building the wall. You don't have to wait for the gypsum to go up there and come back and fire stop afterwards. What's cool about this product also is it allows for 100% movement. There's no sealant that's going to break or stretch. So as long as you have that joint built within the system limits there, you'll get 100% compression and extension. Hopefully this little video works. Hopefully. I'm not seeing it though. Hold on, I have to play it. Here we go. Here's what it looks like. There's the roll. That's our lab manager, Eddie. He's all in charge of all the fire testing at our beautiful corporate headquarters in Somerville, New Jersey. So you just kind of cut it to the length. There is that PSA tape, so you can take that off and stick that down, or just use some painter's tape to kind of keep it in place. And you're building that wall. As I said, you're fire stopping as you're building the wall. You have to get up there and shoot that to the deck anyway. You might as well put the fire stopping on beforehand. Right, and then we're about at the end. We have a few minutes for some Q&A, but I did want to let you know about a really cool interior finish summit that we're going to be having at our corporate headquarters in New Jersey. I hope that's okay, Anne-Marie. But we're going to have we got the right audience here. So if you're interested in Clark Dietrich, Owens Corning, National Gypsum, and listening to some more STI stuff, check us out there. You can either register for Zoom, or we're also, like I said, it's going to be a hybrid event at our corporate headquarters December 3rd come hang out with us. We're gonna have a lot of cool swag and food and stuff. So Anne-Marie, you can come.
Oh, thank you.
Oh yeah,
Anything
so
to
that
get up to New Jersey, right?
yeah, come on up to New Jersey, Somerville, New Jersey. We're about an hour away from New York City, so we'll have some fun there. So Q&A, I guess we have some time for Q&A.
Yes, we do. In some of the last, this a question came in during some of your last slides, and the person is asking if cement is applied all over the pipes, will it serve the FS that's required, the fire stopping?
If there's cement all over the pipe, that's not, I don't know that I completely understand the question, but if there's cement on the pipe and the pipe is passing through the wall, we haven't tested it that way. We might be able to do an engineering judgment if there's some cement that's on there that's not supposed to be in there. Typically, if you can install the amount of sealant that's required within the annulus, within that space around there, it should be okay. I mean, inherently, I mean, we would have to give you a piece of paper that would back it up. I'm not an engineer, I just play one on webinars, but we would have an engineer take a look at it. Usually concrete is not going to be a bad thing, but we haven't tested it that way, so you might need what's called an engineering judgment, if I understand the question correctly. If what you're asking is the pipe is, say, going through the floor or a wall and it's got concrete all the way around it and it has no room, no annular space is what we call it. We call that continuous point contact. So there are some systems that are available, in which case you would put a bead of sealant all the way around there per the system. But without knowing your exact requirement, it's kind of hard. I'm kind of guessing here, but if you want to shoot me an email, my email is right there on the screen, and we'd be happy to take a look at it for you.
Thank you. The next one is, for an example, if a contractor is installing joint fireproofing with red AS200 and runs out of material, are there any issues overlapping and continuing with the blue AS200?
No, I actually have a really cool picture where that happened with a contract with the ES. So you probably, again, are going to need a letter from our engineering folks, especially if an inspector sees it and sees like blue, and then all of a sudden it's purple, and then it's red, because that's what's going to happen in that intersection there. So it's going to actually look like it's 3 different colors. So there's not going to be a problem with compatibility. You just may need to get some documentation from us that says that that's okay. But I would always get that
Another
documentation
question.
before you do that work, and just make sure that it's okay. Like, I wouldn't do that and then come to us. You know what I mean? But it should not be a problem.
Thank you. What is needed information to obtain an engineering judgment?
Right. So for the engineering judgment, you're going to need just about the same information that you would need if you were going to choose the system to begin with, right? So you're going to need to know, in the case of joints, let's just stay with joints here. You're going to need to know what the 2 rated assemblies are. You're going to need to know how big the joint is. The example we showed earlier, if there's anything running through that joint, so any special conditions, and any movement capabilities from your architecturals. So once we know that, typically you're only asking for an engineering judgment because something within the system that we've tested is a little bit different. It's non-standard. Things happen out there. You can't always build it the way you draw it up. So we would basically take either a picture, a drawing, something that you could provide to us with all of that other information I just mentioned, as well as the project name and address. I can't stress this enough. We've been asked countless times from contractors to just do blanket EJs because this condition always happens on every job we're on. We can't do that. EJs are project specific. So make sure to get as many details, pictures, and we need to know where it's happening.
And John, we have just a few more before we end here. So this question, are there any compatibility issues with the fire stop coming into contact with the CPVC sprinkler pipe?
Right, so CPVC sprinkler pipe is typically brand names like FlowGuard or BlazeMaster or So you're going to want to check. Typically, Lubrizol will have a website that will let you know if it's FBC compliant. So you want to make sure, especially or even with joint sprays and joint sealants, that it is FBC compliant, because you may get overspray on those plastic sprinkler pipes. So you want to make sure that if you accidentally spray some AS, I can tell you AS is FBC compliant, so that would be okay. But if you sprayed a product that was not compliant, you're either replacing those sprinkler pipes or you're going to be washing that material off, which is not easy.
Okay, we're down to the last two. First is labeling a code requirement?
Labeling is not a code requirement, but it is a specification requirement a lot of times. It is a best practice, especially in places like healthcare or hospital systems where you're going to have ongoing inspections with Joint Commission or CMS. So just knowing who did the work and what system that was installed a lot of times is part of the facility specification, but not necessarily a code requirement.
And John, this last one is asking, what is the current state of passive versus active fire protection in the code?
What is the current state? Well, they're both in the code, and they're both updated every 3 years. I would say that they're both part of safety layering. You don't build a car and just put brakes in it anymore. You have, power steering and crumple zones and all types of things like that. So they're both going to stay in there. They're not going away. You don't not need fire stopping if you have a fully sprinklered building, because if you put water on a fire, you're going to get smoke. So fire stopping or passive protection is going to help contain that fire and smoke and other products of combustion. So they're all part of the code. They're all going to stay there, and they're all going to continually be updated as new construction methods come up, new products come to market. So always want to check to make sure you're building within code. But I have heard that code is the cheapest way to build something legally. We'll let that one sink in. All right, I think that's all I have, Anne-Marie.
Very good. So that was the last question. So thank you, John, and to Specified Technologies for this presentation, and thank you to all of our participants for joining us today. Please visit awci.org/education for additional upcoming webinars and events. So again, thank you, John, for your time today, and we wish everyone a great day. Stay well and stay safe. So thank you all. Bye-bye.